Welcome to Lecture 10 of Business Decision Making Using Data. So this is the penultimate lecture, but it's the last lecture where we are going through new content. So the last lecture, Lecture 11, it will just be containing some reviews. Okay, so let's get to it. We are still at part 4 of this course, building regression models, and what we want to do is to predict outcomes from data that we have. That would be the X variable. So what is the best model we can build? So what we have done until now is that we have started with a simple regression model. Then we went on to multiple regression model, and then we looked at categorization of the X variables. But today we are modeling time series. And what is time series? It's basically that you can order your data according to time. Okay. Remember that previously we did not use data which could be arranged according to time. For example, we looked at different sites to build a store. Okay, but here with time series you have time on the x-axis, and for example you have y on the y-axis. Maybe it's a price, and for every interval you get a data point, and at these intervals they can be either days or weeks or months or even years, depending on what kind of process you are indeed modeling. Okay, so the agenda for today is that we are going to look at how to smooth data, because in time series you often have a signal or a trend, and you have seasonality, and you have a lot of noise often. Okay, so how can you look for the signal in the data and disregard the noise in the data? And we are going to look at regression models for time series, and we are going to look for where we are going to fit polynomial trends, and we are going to look into autoregressions. So polynomial trends would be time and time squared and time cubed, for example, and you would use that linear time, squared time, cubic time in a regression. And autoregressions, they are kind of, you're trying to explain why, and you using lagged values of y, and these lags can be the previous value of y or something more. Okay, more in the past. And we are going to check some regression conditions, and everything you can find in chapter 7 or chapter 27 of Stina and Foster. So what's a time series? It's a sequence of data points ordered in time. So for example, you have the daily price of Apple stock, or the annual inflation rate. So the daily price of Apple stock is on daily horizon or intervals, and the inflation rate is on annual intervals. Okay, so and of course you can find Apple stock price every 5 minutes or so if you want to. But whenever you have this price, for example, and time, you can actually decompose this into a trend, a seasonal component, and some random component. Okay, and to explain this, I think we are going a bit backwards, because if you have time here, and for example you have house prices, they have a clear trend or over time, and they have a certain seasonal pattern every single year. Always most expensive before school is opening for a new semester, and you have this irregular term. Okay, so for example, you look at the trend, and for example t is measured in years. Okay, and what you would expect is to see like this exponential growth, right? Exponential growth, because the house prices, they are increasing by a certain percentage every year or every period. Okay, so for example, you have the trend, and then you can add season. Okay, so for example, you have added season to your trend, and then your trend plus season, okay, let's see, would look like this. So now you have added the season. It doesn't look like a price process yet, because if you add the irregular term, you are left with something like this, which is like the true price process. Okay, so if you are in the lower pane here, then this is the data that you will see. Okay, and your job is to decompose this last one into the trend, the season, and the irregular. Okay, so for example, then you would be left with like three panes. Okay, like this, and you have the irregular here like this. Okay, this is often centered at 0. Okay, so, and this too. So then you have the trend, the seasonal pattern, and the irregular pattern. Okay, and so the trend is this slow pattern, and the seasonal component is this. If you look at house prices, it would be like a yearly fluctuation, and if you subtract these two from the data you have, you are left with the irregular component. And what you do, a simple forecast would be to just assume that the trend and the seasonal component will continue into the future, and then the irregularity you are left with will give you a measure of how much the process will deviate from the trend plus the seasonal component. And another thing you can do is to look at the trend and the seasonal, or deduct the trend and the seasonal from the y. You are left with the irregular component, and you can try to model or explain as much as possible of the irregular component. For example, by a auto-regression. Okay, so that's a bit about time series, and sometimes you want data which is smoothed out. Okay, so smoothing is actually removing irregular and seasonal components to enhance the visibility of a trend, because often you really want to know what is the trend in the data. So it's really going from something like this to something like this. Okay, and there are many ways to do smoothing. One is simple moving average, and we are also going to look into exponentially weighted moving average, and we are going to look into seasonal adjustment. And one thing that the book is not mentioning is that in addition, you have smoothing based on historic data, and on historic data plus future data. Okay, so that's also something to consider, because if you look at finance, then you often rely on plots, and in these plots, the moving averages, they rely on past data. Okay, so for example, if you make a moving average today, you use the information for example, past 50 days of data to make that simple moving average. Whereas if you want to look at data which might have a seasonal component, then and try to what was the true value of the trend in the past, then you might use future data as well, because you have that in your data set. So the simple moving average, we'll jump to that in the next video.